Welcome everybody. It's good to see you. Pretty full house. Last time I did this, I did it remotely, and I think there were like 4 people in the room. So it's nice to actually do this in front of people this time. Um, I'm Dan Davidson. I'm your IT director. I'll back up a little bit. Um, I want to start off with a little plug for my group. We're in charge of everything computer related for the IGB and for the Carver Biotech Center. So if you're here, in some way, we support you at minimum. So if you have any computer needs, if you have a research project that you need to figure out where you're going to put the storage with, how you're going to do the computation, if you need help technically solving those problems, please come see us. We have had a number of situations over the last year where grad students and postdocs have spent an inordinate amount of time trying to solve these problems on their own, only to end up doing it incorrectly and having to bring us in and us have to figure out how to get them from where they are to where they need to be. So please come see us. We don't bite. We try to be as helpful as possible. Yes, please use us as much as you can. So talking about Biocluster 3, we need to kind of start with Biocluster 2 and why we wanted to move away from 2 to 3. So Biocluster 2 went into service in April of 2017. Its hard drives left warranty in April of 2022. So that means that for a year, every time a hard drive went bad on Biocluster 2, we had to have an old spare drive that was on the shelf that we could use. We standardize our hard drives on different sizes. So the Biocluster 2 uses a standard 6 terabyte drive. Biocluster 3 uses a standard 10 terabyte drive. We are dangerously critically low on 6 terabyte drives because they're all out of warranty. When one goes bad, we don't get a replacement for it. So we really needed to move off of Biocluster 2 because there weren't any spare drives really available that out of an amount that we need. Additionally, the space on Biocluster 2 was getting pretty low. Everybody has in the past seen the emails from me saying, hey, we're running out of space on Biocluster, please delete what you can or archive it. That's still happening. But Biocluster 2 had been low for a very long time, and we wanted to try to find a way to help with that. There have been some requests for some form of backup on the cluster. On Biocluster 2, if you deleted a file, it was gone. There was nothing we could do about it. There was and still isn't any tape backup, but if you deleted a file, we couldn't get it back for you. It was just gone. We also had some issues with some RAID cards. Almost every time you saw us email the list over the last 4 years that said, hey, we have a problem with the cluster, it's from one of these stupid RAID cards. We spec'd a card that we wanted whenever we bought Biocluster 2. And somewhere along the purchasing line, the company we bought the systems from changed them from the card we wanted to a cheaper system or to a cheaper model, and nobody noticed until we were literally running for 6 months and wondering what was going on with the system. And then we realized that, hey, our LSI controllers are not real LSI controllers; they're knockoffs. So we had to deal with that. The old cluster also used a thing called SAS expanders that connects the LSI controllers to the cards. Each system had 2 SAS expanders, and we had a couple of those fail over the lifetime of Biocluster 2. So we wanted to get away from those. It does make it a little bit cheaper, but it also makes it a lot less reliable, in my opinion. The version of GPFS, so GPFS is a piece of software developed by IBM. It stands for General Parallel File System. That allows us to take the 9 systems that currently make up Biocluster 3 storage or the 10 that made up Biocluster 2 storage and make them appear as one file system to everybody. It wasn't supported on newer kernels. So if somebody wanted to get new kernel features, we couldn't update the kernel because that would require us to update GPFS, and the version of GPFS that the whole cluster used was quite old, was getting old as well. So it basically was, any of these were good reasons to move on to a replacement system, but altogether it was like a neon sign flashing that said it was time to move. So this is what the storage for Biocluster 2 looks like right now. It's one rack with 9 45 drive systems. So this has 405 hard drives that hold all the data. So as you can even tell, even though these are newer drives, we have 1 or 2 of these go bad a week because we have 405 drives. The chance of one breaking each week is quite high. But that's what it looks like. So now what does it give you? So what have we done by moving to the Biocluster 3 storage? We now have daily snapshots. So what does that mean? That means if you accidentally delete a file, you have 7 days that we can recover it for you. So, and there's a few caveats to that. The snapshots take place at 2 a.m. each day. So if your file is created at 10 a.m. and you delete it at 11 a.m., we can't do a lot for you there. But if you created your file yesterday and you accidentally deleted it today, we can get it back for you for 7 days. You just that 2 a.m. time is key. That's when it runs. The downside to that, we'll get into downsides later. More storage space. We have over 50% more storage, which you have all already filled up. I have a saying. Disk space is like a gas. Whatever data exists expands to fill it up. So we're already at like 2.4 out of the 2.6 petabytes that we have on the system are already used. So I'll talk a little bit more about that. We have faster RAID rebuilds because we don't have those crappy old LSI RAID controllers. We have the actual LSI controllers that we wanted to do the RAID sets. And part of those faster RAID rebuilds are that we have smaller RAID sets. On the old systems, we had 17 drives, 17 6 terabyte drives that would group together to form a RAID set. And that's kind of like the chunk of data that GPFS uses to store data. So the chances of any one of those 17 drives failing is significantly higher than what we have today, which are 7 drive RAID sets. So your chances of one of 17 drives failing is higher than one of 7 drives failing. And the reason that's important is if any RAID set ever loses 3 drives before it can get rebuilt, we lose all the data on that RAID set. We have technology in place called replication, so that we would have to lose 2 RAID sets on the cluster before any data is actually lost. But losing a RAID set is a big deal. And with these smaller RAID sets, we can get faster RAID. We get these faster RAID, and with the better cards, we get faster RAID rebuilds. When people were hitting the cluster hard, it would take up to 3 days to rebuild a disk under Biocluster 2. With Biocluster 3, if nobody's using the cluster, it gets rebuilt in 10 hours. If it's being used hard, it gets rebuilt in 20 hours. So that's much better than a day and a half to 3 days. So we're very happy with that. We're using a newer version of Rocky Linux, so that allows us to get newer Linux kernels. If you've been paying attention, Red Hat's been doing some weird stuff with CentOS and with Red Hat Linux. Rocky's kind of the alternative that people have been using to get their operating system with that going on. We also have a new GPU queue right now in testing called the GPU test queue. It is free right now. So if you have GPU resources problems that you need to use the free GPU test queue and let us know what you think, because I will start charging for it before the end of the year. Matter of fact, I probably should already be charging for it now. I just haven't gotten around to it. So use it while you can. Right? Also, if anybody has any questions, feel free to interrupt me. We'll have a time at the end, but anytime you need to interrupt, that's fine. So what are our remaining issues? Like I said, we're already low on space again. We found one user who had 170 terabytes of data. That's our main problem. We've been in contact with them, and they're trying to archive that data off the cluster. But we are also going to add in a 10th GPFS system sometime this fall. Probably we'll have to schedule a rebalance. I'm looking at currently thinking maybe doing it over the Thanksgiving holiday weekend so that it doesn't impact business as much. We also have a problem with small files. Biocluster in the GPF system we use was designed for essentially genomic research. And what we have found at the IGB is that there's also what I generically call image research going on as well. And then in part that's Glenn, but the scary part of it actually is not Glenn. We have people with drones that fly over fields and take thousands and thousands and hundreds of thousands of pictures. We have another person who has high resolution cameras pointing at a beehive, taking like 4 different 4K pictures every second of every day for the entire summer. That adds up. And we get millions and millions of these sub 4 megabyte files all the time. And our file system is just not able to handle it that well. Does that mean you can't store it? No, it means you can't. It doesn't mean you can't store it. It does mean that it runs slower than what we would like. It does mean that your program runs slower than what we would like. And it does mean that it actually takes more space than what it would like. The cluster size on GPFS is 16 megabytes. So every time you write a 4 megabyte file or any file smaller than 16 megabytes, you're actually using 16 megabytes of storage. So if you have hundreds of thousands to millions of small files, and if you do, you know who you are. I don't need to point fingers. Everyone knows who they are. That is not the way to do it. So we're trying to work with people to use different technologies whenever we can, but we also recognize that we need to develop a small file system, which is extremely hard to say. But we have an idea for how to do that. We're looking at using Ceph. Biocluster 2 started off as a Ceph storage system. We were a little early on the Ceph bandwagon back then. Ceph is now a stable technology. This would be an alternative to that GPFS file system that we use right now. We can tune it for very small files. It's free, so I don't have to pay $30,000 every couple of years for licensing on it, so that's attractive as well. So we're going to be looking at deploying a Ceph file system probably sometime in the spring of next year, if I had to guess. I would like to get it done quicker. I just don't think realistically we can make it happen before the spring, which probably means it'll end up being in the summer. So we also have stale data that needs archive and removed. And she doesn't know I'm going to do this, but I'm going to introduce Sukan, our new data management person in the IGB. If you haven't met her, hopefully you will sometime in the next year. We're trying to get, she's just on board. We're trying to get her feet underneath her. But she will be working with different labs to try to figure out what we need to do to start managing our data more effectively. And that includes archiving and removing data on the cluster that doesn't need to be there anymore. It was very eye-opening when we moved people from Biocluster 2 to Biocluster 3, because I found data sets that I know for a fact had not been touched since we moved them on to Biocluster 2 from Biocluster 1. So this data could have been sitting on the cluster for over a decade, and there's no backups of it. And when I say there's no backups of it, these parallel file systems, yes, they're supported well, and yes, they're enterprise grade. But if you've been around the IGB for a long time, you know that we have had 2 times when we have had multi-day long outages of our cluster file system because things happen. And it takes a while to fix. If that data is important enough to keep and keep paying for 10 years, one, you need to archive it so that you don't pay for it anymore. Or that it's on a safer place and it's safe for a longer period of time, or you need to delete it so we're just not taking $20 a month from you every month for years on end. And then we don't have near this data storage problem that we have. We also need a faster biotransfer node, which we already have. It's sitting on a shelf. I just need to set it up and install. If you need to move data to other universities or to other organizations, or even to and from campus cluster, using Globus, this will be of great use to you. It will allow you to move your data a lot faster. Our compute is aging. That's what the next half of this talk is going to be about. All of our compute nodes are about 5 years old now. So they're getting a little long in the tooth and they need to be replaced. And we also realize that we need to restart our Biocluster classes. We have had several issues in our group, whether it's illnesses, people having babies, things like that, that have been a very large strain on our group for about the last 2 years. I don't know when that's going to end, but it's been making teaching these classes and finding the time to teach these classes difficult. We understand that needs to change. It is our intention to do so as soon as we can. I'm hoping to get one done this fall. I'm not sure I'm going to be able to pull that off with everything I have on my schedule right now. It may end up being sometime in January. Right? So that gets into the compute part, maybe what most of you are most interested in being here for today. So we sent out a survey at the beginning of October. We had 14 responses, which isn't as many as I would have liked. But it is about as many as I expected. The good news is nobody was unhappy with anything. Everybody said they were pretty much happy with what Biocluster was doing and how the new system was working. What was also good is that it wasn't 14 people from one person's lab who said everybody fill out this form. It was spread out across the campus in many different labs in many different areas. We had people from physics, crop sciences, from inside the IGB, LAS. I think we had somebody from ACES, all over campus. Engineering people were on there also. It was a nice, although it wasn't as many as we wanted, they were spread out very nicely. We had requests for higher cost GPU systems. That was one thing that was noted. We had several people who said they wanted access to NVIDIA A100 systems, which are the most expensive GPUs you can buy today. So that was noted. Most people wanted the GPU systems separate from the main compute, which is kind of the way we've been doing it. So we're going to keep it that way, unless more people step forward and say they don't. What's important to know is that the results of this compute survey are not written in stone yet. So what we propose later on in this meeting today, or in this talk today, if you think that's not going to meet your need, let us know. We still have a couple of weeks for us to make these changes before we order the hardware. More information could sway us on how we're going to do things. Most respondents still want higher memory systems, so we still need to have that available. Installed software and the power of hardware were both tied as the most important feature on the cluster. Cost, surprisingly, was marked as the least important feature. So all of your jobs as of next week will be $100 a piece. And that's a joke. So now let's look. So with this in mind, we had the survey, so we know what people told us. So we wanted to follow that up with what are our users actually doing? So with that, we went and we looked at utilization for fiscal year 2023. And it's not quite fiscal year 2023. This is June 1st, 2022 to June 1st, 2023. And this is a logarithmic scale. Otherwise, this would be so high you wouldn't be able to see anything else over here. And we wanted to be able to tease out a little bit of the details for everybody here. So if you look, most all of our jobs use 20 gigabytes of RAM or less, or are thought to use 20 gigabytes of RAM or less. So that's a good piece of information to know. And then we have a decent amount of jobs here in the middle, but we also have a handful of jobs that people think might need, that's what the orange line is, or will need more than 500 gigabytes of RAM each. So we realize that this is probably, we're estimating this at around 300 jobs a year. people think need more than 500 gigabytes of RAM. And that's a substantial amount of jobs. And they might be very high-profile jobs. These jobs might run for days. If you're running a genome assembly, it's not been unusual for us to see those run for weeks on end before. So these jobs right here, although not high in number, may be very high in importance. So we want to make sure that we still support those, even though the vast majority of our users don't use that amount of RAM. Also means we don't want to overcharge these people and give them more RAM than what they need for the sake of these people on the high end. We want to make sure that we allocate our resources appropriately. Looking at our processor usage, most every job uses one processor. That's kind of what we expected. There are a few that use 70 or over 70 processors. Each node on the default queue right now has 72 cores apiece. So by these people on the high end here, they were using an entire node for their job. These might be genome assemblies. These might just be high processor jobs. But if you look, there's probably about 75, 100 jobs a year who use it. Chris. This is requested.
Okay, so do you have any kind of comparison?
Well, you can't use more than you request because of CPU sets. So that kind of is what we're locked. So that kind of locks it, so that it's not worth looking at.
Yeah, I was kind of curious as if you have anybody that's requesting 70 and only using one.
Oh, it's happened.
Yeah.
Usually we find out about that when we build them. Because if you're using multiplication is wicked. Because if you're using 70, if you run a job that takes 5 days to solve and you're using 70 cores instead of the one that you're actually using, then instead of billing you $5, we billed you $350, and that's enough to grab a lot of people's attention. Yes, but yes, this does happen. Sometimes that happens. But we also have seen numerous times when we had people using a lot. What I kind of did whenever I looked at this graph is I looked at this 30 number. This seemed to be kind of the beginning of the downtrend of everything. So it seems like we have a number of jobs that use less than 30 or less, but not that many that used over 30. That kind of was the split that I saw there. So that leads us to think, we still need a lot of cores per system, but maybe we don't need 70 cores per system. Maybe that's a bit much. So that led us to making some spec change thoughts. The system we spec'd was a 64-core AMD system. AMD, their higher-end server processors are all in multiples of 32 cores, pretty much. So you can get 32 or less, and then they have a few smaller models. But once you get above 32, it's 64, 96, and then 128. We decided to spec the 64-core model because that seemed to fit people's compute needs the most. This would allow 2 of those 30-ish processor jobs to run on each node. That seemed to be a good. Seems to be like it might be a good choice. The cores are faster than what we have right now by, I think, about 20%, so that's a good place to be. Not only are they faster in terms of clock cycle, they also are faster in terms of their capability. So how the instruction set and how it's executed on the processors, you see that's called IPC improvements. You're going to see these IPC improvements make your jobs run faster, even more so than the clock cycle change. We're looking at cutting down the RAM to 1.1 terabytes per node, or that'll be about 17 gigabytes a core. That's about what it is right now on Biocluster 3 on the current default systems. We're also looking at putting in a 15 terabyte NVMe local storage disk. What we have found is local scratch space for many of the applications that we run today is very, very handy, and these things are wickedly fast. Transfer rates are measured in gigabytes per second on these and not in the megabytes per second range, and that's how fast they are. They are insanely fast. I never thought we would see data moving that fast off of a single drive, to be honest with you. We're going to go back to 10 gigabit per second networking. Whenever we put Biocluster 2 in place, one of our big selling points is, hey, we've got 40 gigabit networking that we're using on all of our systems. To be honest with you, no one's ever used it. We monitor the data transfers, and does it go above 10 every once in a while? Yeah, every once in a while. Not enough to argue paying for it. If we find out after we get these new systems that with the combination of the new hardware for the storage system and the new compute hardware that greater than 10 gigabit networking is desirable, then it's just as simple as us scheduling an outage for a node and swapping out the cards on it. The infrastructure's there, we're just not going to use it, at least initially. Our plan is to order 5 of these systems to replace the normal and low memory queue. This will take down the number of cores we have a little bit. But also, unless we've had a node down, we haven't really been using the entire normal queue lately. And we can always buy more later if we see that it is being used. We don't have enough. These are going to be 17,000, almost 18,000 a piece. And if you do the rough math that I use to figure out what you think the cost is going to be, it's going to be about 50 cents a core a day. This number will not be what it is. That was weird. That number will not be what it is, but it is probably in the ballpark. Give me, a nickel to the low side, a dime to the high side on the cost on that. So, and that's actually about half of what you're paying right now. So it will be significantly cheaper. Looking at what our higher memory users will use, we're also going to go with a 64-core system, but this is 2 32-core processors. And the reason we do that is because we need more processors to support more RAM. And we're going to put 4 terabytes of RAM in this thing. It's not going to be as fast a RAM as we have in these systems. Notice this is DDR5. This is DDR4. So that's not going to be quite as good. But it's going to have the same 15 terabyte NVMe storage, 10 gigabit networking, one system for higher memory jobs. If you notice, it's over twice as much. RAM is expensive. And that's really the major difference between the two systems is the RAM. We're guessing it around $3 a core per day. We need to, before we figure out what we need to charge for it, we need to go in and look at what our usage is and see where we need to charge. There also is going to be a break-even point where it might be cheaper to run, say, like a 32-core job using 500 gigabytes of RAM on this one than it would be to run a 64-core job using 500 gigabytes of RAM on this system or something like that. We need to figure out where that is and where it makes sense and how that works for everybody. Getting onto our GPU queues that we're proposing. So everybody in the survey said they wanted A100 units. This is what a system with 2 A100 cards costs. It's a lot of money. These things are insanely expensive. It's going to take us 6 months to get them in because they're on huge back orders right now. So 32 cores, not as many cores. Faster cores, though. Less RAM, same local storage, same networking, the 2 A100 systems. $45,000 a piece for just the 2 GPUs. That's a lot of money. We need to make sure that we need this system before we buy it. We already have 4 A100 cards in the building, and from what I can see, they're not being used that heavily, but they're on a private node. So we need to make sure we understand the use case before we buy these. The alternative is essentially the exact same system, but instead of the 2 A100 cards, we buy 2 A40 cards and we put them in there. These are essentially not top of the line, but they're one step below top of the line from NVIDIA. They are less than half the price of an A100 card. It is my thinking here that we need to start out buying this system and wait for somebody to say that, hey, these A40 cards aren't cutting it for us. We need something bigger. We need something better. And then if we can prove that there's a use case, then we buy one of these A100 systems that are a lot more expensive. So my guess is at the same time as we buy that other compute, we're going to buy one of these A40 systems and start with that. Right? And with that, that is everything I have for you today. Does anybody have any questions, or have I bored you all to sleep? Yes.
For those GPUs, is that a speed difference or is it just a VRAM difference?
It's two things. Well, it all depends on how you define speed. In terms of CUDA cores, the A100 cards have about twice as many CUDA cores as the A40 cards. But primarily, what we have seen is the memory difference that people are most interested in. But there also is, a significant piece of processing in there as well. Yes.
Thanks for your introduction. I'm wondering for the free GPU, what's the memory for that?
Those are 3080 cards. I believe they have 12 gigabytes of RAM in those systems. I think it's a little more than what we have in the 1080 Ti's that make up the current GPU system. Chris.
Yeah, so one of the common use cases that we've been getting from one of the researchers in IGB is deploying workflows.
Mm-hmm.
I know that one of the issues with deploying workflows is you can't run them from the login nodes, standard login nodes.
Yes.
So would it be possible in the next version to have a node where these can be launched from?
I'm not opposed to that. I would like to know who I'm building it for before I build it, though.
Yeah.
So, like, if you want to get us a list of, like, say, 10 people who will be using it, like, that's enough of a use case for me to make sense of building it. Sure. Yes?
Is there any technique can reduce the memory you use? Or common technique?
The memory of a job?
Yeah.
So the memory of a job usually depends on two things. It depends on the program you're using and how well it was coded, and on your data set. You can kind of think of it generically. If you have a 5 megabyte data set, you're probably going to use less RAM than a 5 gigabyte data set's going to use. And also, there are some programs that are written for these 5 megabyte data sets that don't scale up well to like a 5 gigabyte data set. So are there ways in programming to reduce your memory? Yes. If you're writing Python code, if you're writing stuff in MATLAB, there's all sorts of ways and tricks where you can read stuff from a file without having to read it into memory, things like that you can use to save a lot of your RAM. But if you're using a program that somebody else wrote, there's usually not a lot you can do. Maybe break up your data set into smaller sizes. Sometimes that's a workable solution. So instead of running your 5 gigabyte data set, you run 1,000 5 megabyte data sets, and that works out better for you somehow. But that's you're kind of handcuffed if you're not writing the code there. Anybody else? Yes.
So you mentioned that there's still time if people have other opinions.
Mm-hmm.
Is the questionnaire still open? I already filled it out.
The questionnaire is not still open because I'm not looking at it anymore. If you can email me. I'm Daniel D at igb.illinois.edu. Make sure to put in the IGB. You can come by and see us. And the room 130 area down here. You can just email the help at igb.illinois.edu address. If you need to pass on information, those are all ways that you can get a hold of me. Yes.
I guess when you finally get the classes going again, are you gonna announce those through like an email or through the newsletter?
Those classes, when we roll them out again, that they will definitely be sent out to the Biocluster user list. They will also be in the Friday of the week IGB message that most people probably ignore. We don't get a lot of upkeep on the Friday messages, but we will put it there. Yes, Alvaro.
So the data management initiative, I'm still very interested in that because I think
Mhm.
it's a major issue that people are not storing their data.
Yep.
Do you guys have a plan to make it really more available? How to outreach to people?
So we're working on that. We're starting with a couple with what I call friendly faculty. So these are faculty who recognize this as a problem. And Sukan and I are working to understand what their problems are and then try to help them find a solution. Andrew Leakey is our original poster child for this. He has been very helpful in helping us with that, and hopefully we've been helpful to him. But once we start getting our feet underneath ourselves, we actually have a grant that we're going to be submitting, an NSF grant this fall for this to help pay for some of this. Once we get our feet underneath us and we finish getting our tools written, which we're in the process of writing, and we're ready to push them out, then we'll start contacting PIs one at a time, maybe even themes, and then go through it by PIs in a theme one at a time, so that we can kind of start slowly crawling through this. One of the ideas that we've been kicking around is having I'm spitting on the microphone. One of the ideas that we've been kicking around is trying to get each PI or maybe each theme to have a data management contact for that area. So that way we have somebody who knows how to get a hold of the right people whenever we notice something. Right now the tools that we're using for this is it will create a report on your directory on the cluster or on the file server. And it will let you know how much data you have, how many files you have, what's your largest file, what's your smallest file, how many large files you have, how many small files you have, what your largest file is, what your oldest file is, and how big all the sizes are on that. And that's all very good information to help us find like where there might be an issue. So for instance, that data that's over 6 years old on Biocluster right now, like that data right there is prime candidates for you need to do something. And with the report right now, it spits out that information and it's readily apparent that that's what we need to look at. And it is a game of whack-a-mole. So like you bonk one in the head and one pops up somewhere else. But it will get the problem resolved slowly over time. Anybody else? All right. Our offices are in room 130 down here. If you ever need us, please come see us. All right. Thanks, everyone.
Thank you.